Hello and welcome back to the Palaeocast Gaming Network. My name's Dave Marshall and today I am playing Cambria Sword, which, if you believe it or not, is actually a shoot 'em up based on the organisms of the Burgess Shale. So the way that this is going to work is that first I'm going to play the game and you'll be able to follow that along. I've got my Xbox controller and you'll be able to see all the buttons I'm pressing and when. And then afterwards we're going to go through all of the talking points of the level that I've just played. So let's get started. It is completely crazy, as I said, this game. Like, it's completely metal. It is incredibly loud. Let me just turn that down. It's not a paleontology guide, it's fiction. Yeah, so enjoy the introduction. Yep, all seems to be nice in the Cambrian, Middle Cambrian, until the red eyes. Lots of red eyes come down from space. Kind of ruin everyone's day. And then Harris shooting lasers. Brilliant. So they've all been taken over by the red eyes, and they've captured that poor little Picaya and shot our hero off of the cathedral escarpment. So all the evil Burgess Shale animals controlled by the red eyes have kidnapped the rest of them. We don't play this for the story. He's going to get fossilized, surely. The blue eyes. 3 of them. Where's the third one? And they resurrect our hero, who has to go and get the Picaya back, So you've got a normal attack that is just rapid fire, and that can be charged up if you leave it. And then you collect power-ups, which give you modifications to your main weapons or accessory weapons. Yeah, it's just general shoot 'em up. It's really hard. Oh, and keep in mind this is like level 1 and I've already died. Can't even kill that one. So I'm going to die a lot in this. I mean, I do like shoot 'em ups, but I'm not the greatest at them. And you're just going to see my concentration face this whole way through. really close range weapon that is very difficult to use powered up. You gotta get right in there. Oh, it's going well. Encounter with Leoncolia Superlata. Kill it. I suppose it might just kill me, just immediately. I didn't even see that one. Oh, it's shooting jellyfish at me. I'm not sure how that works. And that's my special that I've just used there. And it's still not dead. And this is like the first boss. So many. Is that it? Is it done? And one up after all that, so I've only got 2 lives left. How anyone can, complete this in one go is just beyond me. So, having reached this far, we're going to stop and work through some of these talking points. We start off with the Burgess Shale itself. This is a famous site of special preservation termed a Conservat Lagerstätte from the Middle Cambrian of British Columbia in Canada. It's aged at approximately 508 million years old, so that's 500 million, so the game has got that fairly accurately. The site was discovered in 1909 by the palaeontologist Charles Doolittle Walcott and has yielded thousands of specimens with spectacular soft body preservation. This provided the world with its first glimpse of a relatively complete ecosystem so close to the Cambrian explosion, which at that time was effectively where the whole fossil record started. We now know of other similar sites, including those in the early Cambrian and even before that in the pre-Cambrian. So as time goes on, the significance of this site becomes less and less relative to the others, but in the context of the early study of the Cambrian, it has told us so much about the anatomy and evolution of some of the very first animals in the fossil record. And it's probably for that reason that out of all of the animals in the Cambrian, those of the Burgess Shale are most famous, easily recognised, and therefore most likely to be featured in a computer game. Well, fame is a relative measure, and some are more famous than others, and a case in point is that of Picaya grasslands and Sirota Circus oblita. Picaya holds the honour of being one of the very first chordates in the fossil record, and if that group strikes a note or chord with you, that's because all mammals, fish, birds, even you, are part of this group. One of the defining characters of a chordate, but probably the most obvious feature, is the notochord, which is effectively your spinal cord, and in Picaya we can see this cord running along its back. We also see it has a well-defined head adorned by some tentacle-like structures, which were probably sensory in function. Picaya is found with mud in its gut, so it probably fed on organic debris on the seafloor and spent its days swimming through the water with its flexible eel-like body, trying not to be kidnapped. And presumably that's the threat here. If the chordate lineage is lost, then what is to become of us? Fortunately, Sirota Circus Oblita is here to save the day, somehow sharing in our anthropocentric worldview despite preceding it by about 500 million years. Sirota Circus admittedly is a fossil I was not aware of. Is it a Paleozoic arthropod in probably the world's most famous fossil sites? Yes. Had I heard of it? No. In fact, showing this game an actual Cambrian arthropod researcher, his reaction was immediately just like, why Sirota Circus? It's rarely found, it's poorly understood, and in fact the species name Oblita is after the Latin for forgotten, but then perhaps that's the whole point, it makes the perfect underdog. Now, interestingly, in this game, we see Sirota Circus in two orientations. One with its gills facing downwards, which is the case for most aquatic arthropods, as it tends to work better with gravity. The other facing upwards, which is the position most often interpreted for actively swimming arthropods. These two different orientations are a really nice nod to this various interpretation of how it lived, and it shows some real insight into the animals that the game depicts. So Sirota Circus is zapped by an Anomalocaris falling off of an underwater cliff to its presumed demise. This again isn't just made up in the game, but is fundamental to why we have fossils preserved in the Burgess Shale at all. So all the animals lived in the nicer, shallower and lighter waters, but we actually find the fossils preserved at the bottom of an underwater cliff called the Cathedral Escarpment. So from time to time, sediment would work loose and collapse in giant underwater avalanches called turbidites. Any animals caught in this perished and were fossilised at the bottom, where the chemistry of the sediment worked to quickly coat and replace the remains as they decayed, recording the anatomy of the animals to be discovered some 500 million years later. This also feeds into the interpretation of Sirota Circus as a free-swimming animal. It might be rare in the Burgess Shale because it was able to avoid being caught in these turbidites by being a free-swimming organism, whereas things such as Atoya prolifica, a kind of worm, were so, prolific because they actually lived within the sediments themselves and couldn't escape in the same way. So let's take a look at some of the enemies we encounter, and the first one we see is called the Chulacola cuneata, and this is known from an early Cambrian site in China called Shenzhang. As an organism, the Chulacola is very alien. It has an obvious rectangular body and a tail located high up on the upper or dorsal surface. Along the side of the body are small openings, which are probably gill slits, and so were used for respiration. Like Picaya, its gut can be found to contain sediment, and so it probably swam around eating organic debris off of the seafloor as well. It's hard to pinpoint exactly what the Chulacola and other Vetulicolians were, but they do seem to be closer to chordates, such as us, and echinoderms, such as starfish, than they do to arthropods or mollusks. The next fossil up is Yorgia Wagonrai, which can be found in the Precambrian rocks of the White Sea region of Russia. So the Cambrian explosion was originally thought to be the sudden appearance of fossils, anything older than the Cambrian, and you simply just couldn't find them. Well, we now know that that's not true, and we can find large, complex fossils in the Ediacaran period, which is the one immediately before the Cambrian. Yogya is an interesting fossil. It has a clear head and body and has bilateral symmetry. Well, almost. Bilateral symmetry is what most animals have, where the left and right side of the body are roughly mirrored. And it's pretty much only sponges, corals, and jellyfish that lack this symmetry. So Yorgia has this, kind of, but its segments are alternated so that it's not truly symmetrical. And it's great to see that this little fact that is so obscure for most people was picked up by the game developer. And it is absolutely fundamental to our understanding of how Yorgia is related to all other animals. And it's a long story. Similar to Yorgia is Spagyna flounder's eye. This again is from the Ediacaran period and again is an animal with imperfect bilateral symmetry. Fossils of Spagyna are only found in the Ediacaran Hills in southern Australia, from which the Ediacaran period gets its name. But here they have some great preservation. The fossil itself looks superficially similar to arthropods such as trilobites or even worms, but they all have that left-right bilateral symmetry. So is it closer related to Yorgia, or was it just its own thing? And it's these kinds of questions that are still left unanswered, and they're one of the reasons why fossils from the Ediacaran period are so important to study. Back into the Cambrian period and the Burgess Shale, we find Walcotodiscus typicalis, and this is an Echinoderm, the group which contains starfish and sea urchins. These are famed for their five-fold rotational symmetry, and this is totally at odds to most other animals with their bilateral left and right mirrored symmetry, so they mustn't be related, right? Well, wrong. If you look at the embryological development of echinoderms, you see that they originally start out as bilaterally symmetrical, before the right side of the animal grows into the body and the left side becomes the mouth. And since their anal opening of the embryos develop before their mouths, they're actually closer related to us chordates than, say, a beetle or a snail. Yes, so there was a time when you were little more than just a clump of cells with a butthole. This threatening enemy is called Symlaclavula, and it looks like a huge arthropod, but it's actually a Chulacolian. Now remember the little tail of the Chulacola? Well, Symlaclavula was having none of that, and so it possessed a huge tail of up to 42 segments. And remember how we said that the Chulacola was closer related to echinoderms and chordates? Well, that tail is unlike anything that we see in that group, but it's more like something that we see in arthropods, which has led some researchers to say that Symlaclavula is closer related to arthropods instead, which would mean that also the Chulacola is too, but that doesn't look like an arthropod, it looks more like a echinoderm and a chordate, and so it becomes horrendously complicated. But as I've mentioned, this kind of stuff, these interrelationships between all of these animals, is fundamental to understanding how pretty much all of animal life is related. By now, you're probably all desperate for something simple and uncontroversial, so I present to you Capsuspongia undulata. It's a sponge from the Burgess Shale. It looks like a sponge, has a sponge-like skeleton, and was stuck to the floor, filtering food particles out of the water like sponges tend to do. It's a sponge. This turnip-looking chonker is actually a brachiopod called Micromitra burgessensis, and think of them as like a clam, but understand they are not clams, and people will get very upset if you call them a clam. The opening of the two shells or valves is surrounded by these long and slender bristles called setae, and these often act as early warning systems in brachiopods, allowing them to close their shells up if anything comes and touches them. It's another uncontroversial Burgess Shale fossil, thank God. We now revisit the earlier Ediacaran period and have a lovely bilaterally symmetrical fossil called Parvankarina minchemi. This is known from both South Australia and Russia and is thought to either be an arthropod or a mollusk. And whilst the argument of what it fundamentally is is still ongoing, we do know that they used to like to align their bodies with the current. And it's funny these kinds of intricate things you can discover about fossils whilst not understanding the basics of what you're looking at. Our first boss battle is with Leoncolia Superlata, and this really is a spectacular specimen. It belongs to a group called Megachirons, or Great Appendage Arthropods, and it really does live up to that name. At the front of the animal are two large appendages with long whip-like extensions called flagellae. It's thought that Leoncolia used these flagellae to feel its environment, and since its mouth is located at their base, they were likely involved in finding food, making Leoncolia a scavenger or a predator. It also had other appendages along the length of its segmented body, including clawed feet for scratching at the seafloor and large flat gills that could be flapped for breathing and limited swimming. Finally, shooting out of the mouth of Leanchoilia, for some reason, is the sponge Choya carteri. This is a spiky, oval-shaped sponge that stood on the sediment with stilt-like spines. A very weird animal, but that's only relative to the animals we have present today. It's definitely worth remembering that all these animals were successful in the conditions of their own time. So that wraps up this first video. If you've liked it, then please let me know and I can grind through all the other 7 levels of the game. Which animal has been your favourite, and which obscure animals around the Cambrian explosion would you be most keen on seeing depicted? Let us know in the comments section below, and don't forget to subscribe for more great paleo gaming content.